Welcome everybody at session number 6. This is about one of the most interesting compounds, pollutants we have, oil and hydrocarbons. Why is it interesting? It is among the most frequently found compounds. All countries in the world has a lot of contaminated sites with oils and hydrocarbons. It is also an interesting group of compounds with all different toxicology, different mobility rates, etc. So I think we have a very interesting session ahead of us. It is mainly about solutions, a lot of remediations of oil and hydrocarbons contaminated sites. So I'm looking forward to this session. I introduce myself. I'm Frank Zwartjes from the Netherlands. I work for the National Institute of Public Health and the Environment. I work with soil pollution for 35 years, and I more or less covered all aspects of contaminated sites. I'm not going in detail. And I'm very happy to chair this session together with Thomas and Robert today. Tom, can you please also introduce yourself?
Yeah, sure. My name's Tom Asprey. I'm technical manager for a UK-based remediation contractor called ERS. And today I'm also representing the Scottish Contaminated Land Forum, so a volunteer organisation focusing obviously on contaminated land in Scotland and the UK. Thanks.
Thank you. Robert, can you also introduce yourself?
Yes, sure. Good morning, everyone. My name is Robert Dieling. I work for State Geological Institute of Geochemistry in Slovakia, where I'm dealing with a variety of natural and technological hazards. This basically includes investigation and monitoring of polluted sites coming from different sources, usually chemicals, petrochemical industries, energy producers, former military bases, and also mining activity, mineral processing. And I'm mainly interested in geological and hydrogeological aspects of polluted sites. Thank you.
Thank you very much, Robert, for this introduction. Again, I ask if Joachim is present to give his first presentation.
Hello, I'm Jan here, and I will represent Joachim, and I will give the presentation. So
okay,
I'm
okay.
Here. I was just in the wrong session, so I just.
Oh, you were in the wrong session. Okay. Well, you're just in time, so no problem. I give over to Tom, who will introduce the first speakers. Tom, please go ahead.
Thanks. So, yeah, our first speaker is Jan Hamers from Hamers Technologies, and he will be giving a presentation on in situ thermal desorption with reburn method of hydrocarbon contaminated soil in urban area. So I'll hand over to you, Jan, for your presentation.
All right, thank you. Can you just allow me to share the screen?
You can share your screen yourself.
It says that you have deactivated the screen sharing. So.
Oh, when you share your screen, it says that it is it's deactivated.
Yeah, that's what it says, and it's because I had to join the session, but not as a speaker, because I didn't have the right link. I had the link to the other session, so I finally.
Oh, okay.
But if you can just allow me, then I can share the screen.
The question is if we can do that, or do we need Marco? Maybe. Let me see. I'm very much afraid.
Frank, which problem do you have?
Ah, you're there, Marco.
Oh, hello.
Jan Hamers is not able to share his screen, Marco.
May we postpone his presentation at the end? Maybe we can.
Or just switch so that I can join in. Maybe Marco, if you send me the proper link to join this session as a speaker, and maybe the second one can do this one, and then I'll just talk afterwards, if that's okay.
Wait. You are not able. Try now, Jan, if you are able to share your screen.
Yep, now it works. Okay.
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 Excellent.
That was so we can maintain the original schedule.
Yeah, that's much better.
Okay.
Let's do that. Here we go.
Yes.
Yes, can everybody see it?
Yes.
All right. Well, now that we're all said, hello and good morning to everyone, and thank you to the organizer. Thanks to the organizer for giving us the opportunity to present just a very specific case, which has been executed at the end of last year for in situ thermal desorption, where we reburn, and I'll tell you what that is, in a very urban area. So in a few words, what the company, the presentation will go about. We'll have a very short presentation of the company, the context, pretty important, how the solution has been designed, and then the results of the full remediation. Now, who are we? Hamish Technology. We're a small technology provider. We do soil remediation by thermal desorption. We do nothing else but thermal. It's own technology. We patent it. We develop it for over 25 years. We're based in Brussels, Belgium, and we operate all over the world. Not as a contractor, as I said, but as a technology supplier. So we work through different local companies wherever we work with. So this is a little bit of our operations. We're European based, and we've been quite active in North America, Asia, and that's by and large most of the activities, not much. The reason why people choose thermal, and I'll get into that in this presentation, is more or less because of certainty and predictability and the willingness to go quickly, to get rid of the problem quickly, and to get rid of the problem in a definitive manner, not to bother about risk assessment. So there is a hell of a lot of remediation that is based on risk. Usually thermal desorption is not based on risk. It is, we want to get rid of the source as a definitive way of dealing with the problem, and not to being dependent on any future risk assessment. I think it's a pretty much it's a pretty important philosophy in which we operate in this world. You can either choose to manage your contamination or to remediate it definitely. So this is a reason why this technology has been chosen in this case that I will present you. By and large, what is thermal treatment doing, and what can it do in general? It is suitable for treatment of all contaminants except heavy metals. So of course, heavy metals we cannot treat, with the exception of mercury, but it's focused on treating organics, and 70% of the thermal projects in the world are done with hydrocarbons or PAHs. Now the technology, how does it work? As you can see here on the left-hand side, it's inserting heating elements in the soil. And how do you put heating elements in the soil? Well, you drill them. They're in steel, and it's actually two pipes, the one in the other, the one inside the other, and there is hot air circulating in the pipe, not in the air, but only in the pipe. So now, what happens when hot air circulates in a pipe? It means that outer pipe, it's getting warmer, typically 400 degrees, something like that. And then, and this is a very important word, by conduction, the soil is getting warmer and warmer and warmer. And now what happens when the soil is heating is that the contaminants, or at least the volatile or semi-volatile contaminants, vaporize. What happens when they vaporize? Well, they need to be collected, or they would go anywhere else. So there is a separate vapor extraction network, which is not to be mistaken for soil vapor extraction. It's a vapor extraction at very low negative pressure that recovers those vapors from the soil in order not to, have them condensate back or just go anywhere else. And what is called reburn, which is what we have applied, is happening here at the surface. Once those contaminants, so in this case hydrocarbons, are collected at the surface, they're no longer contaminants. We rebaptize them and we call them fuel, combustible. And that same fuel is used in these proprietary burners to generate heat, which heat is then used to heat the soil. So there is no vapor treatment system, because the contaminants themselves are 100% recycled because they are burned and so they're used as combustibles, as fuel source. So that's in a nutshell how the process works and how it's been applied. And I'm glad also to see that many recent publications have ranked this technology as top, I mean, in this case, #1 as the most sustainable technology when you take sustainability as a whole, not just carbon footprint, but you take the social aspects, you take the fact that you can completely reuse the soil, you take the effectiveness and the speed, and so the impact on the overall has put this technology as if not the, but at least one of the most sustainable of all. Now, the context of the project I'm talking about. This is a site location. It's in the suburbs of Brussels, in, let's say, the more richer suburbs of Brussels. It's an individual house. It's in a villa. There was an underground storage tank for heating, and that has been leaking for ages. A new owner comes in, says, I'm going to buy the house. There is a regulation that says you cannot buy property without looking at the soil, and the government tells you then you can or you cannot buy it. In this case, it had a risk of contamination. They did the investigation. It was contaminated, and remediation needed to be done before the transfer could happen, or in this case, a transfer could happen, but a bank guarantee was put in place so that the remediation would take place. The choice of thermal was pretty straightforward. The new owner wanted zero contamination left behind, so there is a level to achieve in the Brussels region, which is, yes, call it by and large background. In Italy, it's called Tabella A, and here it's category 1. Every country or region has its own qualification for that, but it says if you're below that, we guarantee that there will be no further action required and there is no contamination left behind. So that's essentially what the target was. As you can see here, this is the house, and this is the underground storage tank, and this is the contaminated area. It's 7.5 meters deep. It's only 28 square meters, so it's not a lot. It's in a pretty quite a nice area. An average concentration just shy of 5,000 parts per million, and the target is 300. Peaks were at 17,000. It's very urbanized. It's very quiet, and people didn't want any nuisance or trucks or whatever in their area due to that remediation. So what was solution design? 16 heating elements, 7.6 meters deep, so a little bit deeper than the lowest contaminated point. The reburn technology, which I briefly introduced to you a few slides ago. Interdistance, pretty short, 1.5 meter interdistance between each of the heating elements. Why is that important? The closer heating elements are to each other, the faster it goes, and the more effective it is from an energetic standpoint. Now, of course, the closer you put them together, the more drilling you need to do, so the more expensive it becomes. So there is an optimum, and the optimum is usually close to 1.5 meter if you heat with, let's say, burners. If you start to heat electrically, not to be mistaken by resistive heating, but just conductive heating, but electrically, you have the same rule, but there is not as much electricity available. Whereas when you work with natural gas, which was the case here, you don't have an issue with availability of energy. There's been some diagonal drilling, meaning that there was contamination under the house as well that needed to be removed. So you'll see some of the drillings were done from the outside under the building, and the target temperature 250. How is that decided? Essentially by lab tests or kinetic tests, where the temperature is the temperature and residence time is essential to guarantee that there is no, in this case, fuel oil left behind. So you may think, is it boiling point? No, it is not boiling point, because of course boiling point would do the job, but it's higher than that. But you can vaporize products at a lower temperature than the boiling point, provided you keep it at a sufficiently long residence time. You can you can evaporate water below 100 degrees. When you go wash your hands, it's never getting 100 degrees. You just aerate enough and you wait long enough until it's completely vaporized. That's by and large the same principle under in situ thermal desorption, is leave it there enough, and 250 degrees, what's implicit here, it's 3 full days, 72 hours at 250 degrees, always does the job for the diesel kind of contamination we're handling here. Noise was important. As you can see here, this is the wall of the house, and there is a little window here, and this is the sleeping room of the people, of the owners of the house. So they wanted to sleep well and properly. So it's the only rotating part in the whole process, and it's the only source of potential noise, so it needed to be insulated, which it was. And then, of course, they could sleep. You can see some drilling work, a little bit invasive. That's the only rough and tough part, putting the drilling. It's a rotating auger, pretty simple. In this case, it's at 7.6 meters under below ground level, just in front of the house. The house is still accessible, not the garage, of course. And this is once the burners are installed. What you can see here, it looks like they're drunk, those pipes. They're not. These are the inclined wells that go under the garage and under the house. Results. How long did it take? As you can see, it started September 16 and ended actually end of October. So it's 45 days of treatment total. So as you can see here, we stopped, and what you see is the main driver of remediation progress is temperature. So you see the temperature in the soil after a few days already reaching 100 degrees, and in every in situ thermal remediation we see a plateau at about 100 degrees, just the time it takes to vaporize all the water in the soil. During that period, there is also hydrocarbons removal, but the main process is water removal. And then once it's dry, you can see temperature going up and up and up and reaching the target temperature of 250 degrees. Then it's shut down, re-moisturized. Water is put back in place to guarantee that the soil is as it was before, and also for stability reasons. Control sampling is done by an external firm, and done. Emission controls, there is one single emission, which is the combustion gases, and of course the reburn gases go to one single point, and there is it has to be checked and measured. We measure it on a continuous basis. The standard emission parameters: carbon monoxide, NOx, SOx, hydrocarbons, and they were all continuously measured and monitored by the authorities, and they were way below the norm. And there's been obviously no complaints, because you could see also the environment, very, very urban, with people, people and kids, etc., living in the area. There's no way you could have anything smelly out of that chimney. Results, as I said, you remember where do we start from? 4,900 average, 17,000 peak. That is from the survey. Actually, was a little bit more once we drilled the samples, we drilled the wells. But by and large, these are the results: TPH C10 C40, 1 point at 130, and then the rest below 100 or even below 50. The target was 300, so we were well below the target, and that was it. So essentially, this was good enough to go back into the category 1. So essentially, what is also called multifunctional use in the Brussels region, and to have a new owner happy and a former owner happy and released of his liability. So as a conclusion, in this case, and as in many cases, well, the thermal desorption was pretty effective on hydrocarbon contaminated soil. All included mobilization, heating, validation, and demobilization was 4 months. So the owners were disturbed for 4 months of their property. There were, to say this, very, very few nuisances in the area. No trucks, no excavation, no dust, no noise. It was looking quite clean and you know, no issues with neighbors. Said no earth movements. And I think the most important result achieved is that this piece of property is now fully recovered for residential use, for actually multifunctional use. There's no contamination left behind. So the job has been done. The legacy has been taken care of. It's completely remediated. And that's it. And that is the full achievement of this project and usually of this technology. So I thank you for your attention, and I hope I stayed in the timing. So I guess that was the case, and be ready to answer questions as the chairs allow to happen. So thank you.
Thank you very much, Jan. No, very good timekeeping, actually. In terms of questions, we'll keep all the questions for speakers for the panel discussion at the end, but please put them into the chat box. Yelena, I think I've seen you. Are you there? Can you share your screen, please?
Yes, hello.
Brilliant.
Good
Hi.
morning or good afternoon, depends where you are. Just a second to share the screen here. Okay, and where is my presentation? Okay, this is. Okay.
Great. Okay, so I'll just introduce Yelena Milic from University of Belgrade, who will be talking about natural sorbents and microbes, use of natural sources for decontamination of oil contaminated waters based on the principles of sustainable development. So I hand over to you, Yelena, to give your presentation. Thank you.
Okay, well, thank you. Hello once again, and thank you for this opportunity to represent our work. This work is dealing with natural sorbents such as organominerals, zeolite and bentonite, and with microbes isolated from environment. Since both of them are the natural sources for possible decontamination of contaminated area. In this case, in this experiment, we were using those sources for cleaning the oil contaminated waters. And we choose this approach, and this is how to say, our preliminary results. This was our first experiment, just to give us the direction for other more in-depth experiments which are planning to work. I will use just this opportunity to present our small group. We are the part of Institute of Chemistry, Technology and Metallurgy, and we are National Institute of University of Belgrade, based in Serbia. So our group is mostly working at the field of environmental protection, and we're actually working with microorganisms isolated from the environment and trying to use their metabolism to decontaminate some of area in Serbia. So for this work, I put here three main points. First of all, we use, as I mentioned, mineral sorbents. For us in Serbia, they're easy available and low cost, because Serbia have natural sources of mostly the zeolite. And we want to check them that from our resources, the sorbents from our resources, to check their properties for a removal of different kind of petroleum substances. It is since they are sorbents, it is we use the sorbent methods. The idea is that use adsorbents which have a laborious surface. And that surface is capable of binding molecules onto them. And As well, we use specific microorganisms which are already using in bioremediation experiments. It is strains isolated from the contaminated areas in Serbia. Mainly, it is an area from a raffinery or from some spilling of oil on some gas stations, for example. And those microbes have a natural capability to degrade and transform petroleum pollutants because of their metabolism, and which is what is very important. They don't create secondary waste during this biodegradation process, which is very important for sustainable development, actually. So the aim of this study was to investigate the potential application of modified mineral sorbents for the removal of oil from waters. We checked two types of pollutants, crude oil and diesel oil, and two types of natural sorbents, organozeolite and bentonite. At the first phase, the absorption capacity, we checked the absorption capacity of sorbents for these two types of pollutants. And on second phase, we did the biodegradation and measure capacity for biodegradation by respirometer and GC analysis. On this slide, you can see the small chart of flow, of this experiment. So we are using organomineral and we absorb the pollutants onto them. Actually, we put the organomineral into contaminated water. Stir it for some period of time, and after that extract organomineral, and we are expecting that pollutants will be attached to that organomineral. After that, we inoculate that organomineral with biomass of biodegradation microorganisms. And as you can see here, we have all circulated process. It is all in the loop. We don't have some big waste, because our idea is that we are getting the biomass from the process, and it can be used again in microbial degradation, and we are getting the organozeolite, which can be regenerated and use it again in this cycle. So this is our preliminary experiment. As you can see, I split them on organozeolite and bentonite. And at the first phase, we measure the adsorbed pollutant. As you can see, the diesel oil has much better results for adsorption on both of those minerals. And second phase was biodegradation, and I put here two results. Actually, both of them are percents, but it depends on starting concentration. So we calculated as a percent of adsorbed masses of pollutants and as initial masses of pollutants. So there is a difference actually, because we are getting different results. So if we are looking to the crude oil, it is much better. It is biodegraded or much better than diesel oil if we calculate it from the adsorbed masses. But however, since crude oil do not have a good absorption, that's why when you calculate it from initial masses, these percents are dropping down. So this is the charts prepared from the results from the respirometer, and they are in correlation with the previous table. They are showing the consumption of oxygen and the production of CO2, and we can see the respiration of microbes during this process. And what is important, as I said, this is just our preliminary experiment, and we want to check. We didn't know what we are going to get, I have to say, because we never used this kind of zeolite and bentonite from Serbia with our microbes. Our microbes are as well isolated from Serbia area, but it was used on for soil bioremediation and without adsorption. So taking into account those results, we can conclude that this method is maybe more suitable for cleaning diesel oil from contaminated waters, and bentonite as adsorbent gave the best final result of cleaning capacity. However, we need a lot of further research, and we need to find a good combination of adsorbent and pollutant to find the best match to have the best results, because adsorption properties of this kind of mineral sorbents can be modified, and that is giving us opportunity to modify it for different kinds of pollutants, and to use that way to find a good combination of adsorbent and pollutant. We think this is a good method, but it needs to be laboratory checked for every adsorbent and pollutant combination before using in the field experiments. So thank you for your attention. And if you have some question, I can answer at the chat as well. Here is my email address, so you can send the email question as well.
Thank you very much, Lelena. Yes, as said before, put your questions for Lelena into the chat, and we'll pick up some of those later on in the panel discussion at the end of this session. So our next speaker is Marcelo. If you would like to share your screen, Marcelo.
Yes. Can you see it?
It's coming. So I'd like to introduce Marcello Carboni from Regenesis, Italy. Marcello is the regional manager of Europe for Regenesis. Regenesis are a global leader in situ remediation of contaminated groundwater and soil using injectable substrates. Since 2011, Marcello's been coordinating technical and sales teams throughout Europe and provides business development in new countries as well. So Marcello's title is Novel and Developing Uses of a Colloidal Activated Carbon Amendment for the Treatment of Petroleum Hydrocarbon Impacted Sites. And I'll hand over to you for your presentation. Thank you very much.
Thank you very much, Thomas, and good morning, everyone. My presentation today is about non-conventional uses of Petrofix, which is a colloidal activated carbon we have introduced in a couple of years ago, specifically for the in situ remediation of petroleum hydrocarbon sites, such as petrofilling station, for example. But then, through the years, we have seen an increasing interest by clients on using it in different scenarios, and this is where I would like to focus today. So first of all, what are we talking about? We are talking about colloidal particles, very fine particles, 1 to 2 microns of activated carbon, which is a stable suspension into water. So it becomes basically a liquid. And this can be applied in the subsurface. It will move very homogeneously. And then after weeks, it will coat the soil particles. And from there, being activated carbon, it would sorb the hydrocarbons from the dissolved phase. And the sorbed hydrocarbon then is biodegraded, and this biodegradation is promoted also by nitrates and sulfates, electron acceptors, which are included in the blend, is this white powder you're seeing now in the video. This biodegradation provides self-regeneration of the Petrofix, so which becomes not consumed during the process, so it will stay there on the long term. This provides an easy and safe way for remediating hydrocarbons, which became very interesting, for example, for traditional sites such as petrofilling station or other hydrocarbon site, because it's easy to use, low pressure involved, non-hazardous compound compatible with any material, and provides a long-term, completely passive management of remediation without active equipment on site. Apart from that, increasing interest has been seen in the use on Petrofix for subsurface oil spill response, injectable permeable reactive barriers, and preventative approach on non-contaminated sites. And those three scenarios is where I would like to focus today, starting from oil spill response scenarios. So whenever a spill occurs, it is a matter of weeks or few months, and then the contamination migrates, and these generates expanding risks and liabilities on site and off site. And the primary spill response usually focuses itself on reducing the scale of the impact and removing the majority of the mass. But there is, after the primary spill response activity, usually some residual mass present, which then through the time migrates and continues to spread, so increasing the size of the contamination. And if I deal with that contamination at the remediation stage, which generally speaking it comes few years after the spill occurs, then it is likely that the cost for this activity and the complexity will be very high. So from there, the idea to anticipate this migration, making advantage of the Petrofix. So just after the primary spill response is set up and in place, we can then shortly after follow up and manage those risk and liabilities which are still under the migration process. One example could be installing a Petrofix barrier to protect off-site migration or to protect sensitive receptors. The interesting thing about it is that Petrofix does not consume over time, so it's a very long-lasting amendment. So I don't need to wait for the contamination to already be there to install the barrier. So I can anticipate the migration and the plume formation, installing this barrier today and to protect then receptors on the longer term. Another option could be support the source area management with grid injection, or also, for example, with direct application into excavation. For these, it is possible even to apply this spray, which makes it very handy, very easy to be applied. On domestic oil spill scenarios, similar activities which could be done. Another option could be implement the Petrofix into the pipeline bedding, which frequently become preferential migration pathways for the contaminant to arrive to sensitive receptors. So here, the fact that Petrofix is a liquid, it can be inserted into those high permeability bedding with low pressure, and it will coat, it will permeate through the bedding and therefore inhibiting this preferential pathway very easily. An example of this in Europe comes from Seed Environment. This is an oil spill response company, which was probably one of the first one in Europe to adopt Petrofix in their spill response package. In this domestic oil spill, what they did is just in a matter of few months after the spill occurred, to protect with two Petrofix barriers the sensitive receptors such as a residential housing and a small river which was flowing down gradient. And this activity is very simple. So for whoever is involved with injection, it can be done direct push, so no excavation involved, very low interference with surrounding ongoing activities, and no issues with accessibility in small areas. So let's get now to the second scenario, which is the use of Petrofix for so-called injectable permeable reactive barrier. So conventional barriers such as permeable or impermeable barriers frequently are used to cut off off-site migration, so to contain a plume or to confine source areas or highly impacted areas. Those usually become a very impactful intervention, and it's easy that they come to high cost. And on top of this, the fact that I replace natural soil with reagent material makes that I manipulate the hydrogeology. With that, it is a potential issue, the fact that they can suffer from crockling, from bypass processes. Converting this into an injectable barrier solution provides the fact that I leave in place the natural soil, so I do not provide modification of the natural hydrogeology. So the flux and the transport of contaminants will remain unchanged, and the solution much easier, especially when I'm talking of big size, can be much more affordable economically. And the fact that I can use Petrofix for such scenarios provides the advantage that it's a liquid, so it's very easy to inject and distribute it homogeneously. So it's very likely that I can create a very continuous barrier, which is what I need for such kind of treatment. And also the fact that it's lasting on the long term, I don't need to go back on site, not even after years of time. And this Petrofix will manage the plume on the long term. On such scenario, another example comes from the UK. This is a redevelopment site. In this case, the site was suffering from contamination coming from up gradient, from another contaminated site. So the need for the builder was to protect their lot to avoid any risk for the new residential and commercial housing. The primary idea was initially to build up a slurry wall, but the size, we're talking about almost 1 kilometer, was making this solution prohibitive for the building up and construction, but also then on the long-term maintenance, because then there is need to maintain the groundwater level stable and avoid any build-up up gradient. So this was then converted into a much easier Petrofix injectable barrier. So this was a much more affordable process. And on top of this, the interference we had with building activities on site was minimal. So the two activities could go and proceed absolutely in parallel. Let's go quickly to the third and last scenario I would like to show you today. This is preventative treatment. Preventative means that I do apply Petrofix in areas which today are non-contaminated. This comes from the recognition of the fact that whenever an oil spill occurs, then it is likely that the majority of the mass then will go and sit into tank or pipeline bedding, into service corridors. And these will soon form primary and secondary sources, which then will spread on the surrounding soil and groundwater environment. So from there, the idea that any area which is at risk of potential contamination, so UST bedding, above ground tanks, pipeline, or any service corridors, could receive an application of Petrofix up front. So here, the advantage is that Petrofix, again, being liquid, it can be spread and it will distribute homogeneously in those high permeability backfilling material, and will coat all the surface. And again, staying there on the very long term, then whenever a spill occurs over time, it can be even in many years, the activated carbon will still remain active to manage this spill. Another option is whenever, for any reason, I need to make an excavation, before backfilling with backfilling material, I can spray apply the Petrofix on the walls and on the bottom of the excavation. This will provide that over time, the backfilling material will not form, will not risk to be recontaminated again. And this is exactly what a client of ours did in Germany. There is a chemical plant. They needed to install a new service pipeline underground, which was passing through contaminated soil that could not be remediated entirely. So they provided the excavation for installing this pipeline. And the excavation remained with surrounded contaminated soil and underlying contaminated groundwater, which was probably then over time go and recontaminate again the backfilling material of this pipeline, and then creating a preferential migration pathway, because this backfilling material is more permeable than the natural soil. So in order to avoid this, what has been done is spray applying the Petrofix on the wall and on the bottoms just before the backfilling. And this activity is very simple. So it lasts just a few hours, and then immediately the backfilling can be put in place. And it's just mixing and the product with additional water, and then applying it with traditional equipment. Okay. With that, I finish. Thank you very much for your attention, and I will hear you back in the Q&A session at the end. Thank you very much.
Thank you very much, Marcelo, for this very interesting examples of the success of Petrofix. Robert, you take over the next few sessions.
Yes. So
yeah.
Next presentation will be given by Matthew Lemoore. Are you available? Can you upload your presentation?
Yeah, hello.
Okay. Let's see. Okay, so I can introduce you. Matthew is an environmental chemist working at the University of Bordeaux, France. His research interests revolve around the use of natural tracer 222Rn for the detection and quantification of natural contaminations in the critical zone. He is also involved in several other projects for water, sediment remediation in big deltas such as the Mekong River. The presentation title is Effect of Naphtha Mixture Composition and Alteration on 222 Rn partitioning coefficient, implication for naphtha contamination quantification. So please, Matthew, the floor is yours.
Thank you, Robert. Good morning. So I am Mathieu Lemer. I am a postdoc at the University of Bordeaux, and I thank the organizer to give me the opportunity to give this presentation about radon partitioning coefficients. Soil and groundwater are often contaminated by complex organic mixtures such as non-aqueous fast liquids or chem NAPOL. These liquids are recognized as a critical issue in environmental remediation. They can persist for centuries in soil. It is then crucial to detect, localize, and quantify NAPOL. Traditionally, NAPOL contamination have been estimated using drilling or core sampling, but it's time-consuming and quite expensive. Gas monitoring is also encountered in the literature, but is also time-consuming. Finally, artificial tracer injections in soil has been used, but is also time-consuming and quite harmful for the environment. So it is needed to give new opportunity to detect NAPOL in soil. Radon, so it is a 222 radon, can be used for NAPOL tracer. It is a natural component encountered in soils. It is a noble gas and has an half-life of 3.82 days. It is easily to use it because it has an affinity with organic phase. When groundwater containing radon migrates toward a residual NAPOL contamination area, a local radon deficit is observed. The radon deficit close to a NAPOL contaminated zone depends the radon partitioning coefficient. So the radon partitioning coefficient is of pivotal importance for the quantification of NAPOL in the soil. This partitioning coefficient can vary with different aspects, such as the chemical composition of NAPOL. Indeed, if it's diesel or gasoline in soil, the chemical composition will be different, and the partition coefficient can vary. The evolution with time, also such as the evaporation of NAPOL or the degradation, can also take some variation for the partitioning coefficient. But no study in the literature has been dealing with this, such as the degradation of NAPOL and the variation of the coefficient partition. So, several partitioning coefficients have been mainly reported in the literature, but for synthetic NAPOLs. Also for commercial NAPOLs, but also for synthetic NAPOLs. And it is no data for commercial NAPOLs and degraded NAPOLs has been encountered in the literature. So this study is first to determine the partitioning coefficient for commercial NAPOLs, such as diesel or gasoline. The study of the effects of the NAPOL degradation. So we studied two degradations, the evaporation and the UV degradation. And after all, the third aims of this study is to see the relation between the partitioning coefficient and the molecular composition of the NAPOL. For that purpose, the reach of this goal was to make batch experiments to determine the radon production. Okay. After that, fresh and diesel and gasoline were sampled at a few stations and investigated using GCMS to characterize their molecular composition. The degradation of the fresh NAPOLs was realized through evaporation and UV degradation. And finally, the water NAPOL partitioning coefficient, the KNW in this study, for fresh and degraded complex NAPOL were determined using batch experiments. In order to determine the production of the radon in the soil, two sets of batch consisting of 6 bottles, as we can see on the image, with different water contents were realized. the soil was coming from the same area. It was just a pond front of the laboratory. But two different depths were used, so 20 centimeter and 70 centimeter depths. And afterwards, the production of the radon was calculated. So all the different sets of experiments were performed in a 1 liter glass bottle, as we can see, and sealed with rubber to prevent any linkage. After that, a mass of soil was inserted in the bottle, and humidification was realized at different water content from 0 to 0.2. After that, we realized the degradation of the napple. So first, we bought some fresh gasoline and fresh diesel from a fuel station, and we degraded it in two ways. First, the evaporation, which was just an evaporation under the wood to remove the volatile compounds. And the photodegradation were carried out in a photolytic reactor, which consists in a 1 glass bottle, as we can see down on the photo, and a UV light was placed close to the reactor. And after that, everything was wrapped under the aluminum foil, and the reaction occurred for 2 hours. To give more information about the molecular composition of the fresh and the degraded napples, we used GCMS. So it was GCMS in 2 ways. The first way was the liquid GCMS, and the second way was the headspace GCMS. Indeed, the headspace GCMS allows us to detect the most volatile compounds and have a good separation also. So it was suitable for diesel fuels compounds. The liquid GCMS was also suitable, as the diesel contains heavy hydrocarbons, and it is easily detectable with this technique. After that, in order to get information about the partitioning coefficient of fresh napples and degraded napples, we did ads for the production of radon of the soil batch experiments. We put the same soil inside the bottles, and we humidified at the same water content all the batches. And after that, we introduced the napple inside the bottle at different content also. And after that, after 20 days of equilibration, we can measure the batch activity by removing the gas inside the bottle using a scintillation flask. And after that, we can get the activity of the radon for each batch. So concerning the results, the first figure is giving the production of radon for the different batches for the soil at 2 different depths on the soil profile, at 20 centimeter and 70 centimeter. What we can see is that we have rapid increase of the radon activity with the humidification of the batches. And after that, we get an equilibrium at the 2 depths. However, at 70 centimeter, the radon production is lower than at 20 centimeter. Here we have the results concerning the radon activity that can give us the partition coefficient for the different napples. So here we have the diesel. On the left, the fresh diesel. So the points correspond to the different batches, and the curve correspond to the modeling gave by the equation of the activity. And after that, we fit at the best to get finally the partitioning coefficient. So for the fresh diesel, the partitioning coefficient is 60.7. And when we degrade the diesel, so under UV in the middle and evaporated on the right. In the middle, we can see an increase of the partition coefficient. And at the opposite, when we evaporate, we have a decrease of the partitioning coefficient. So we can see that we have a variation of the partitioning coefficient between fresh and degraded diesel. Concerning the gasoline, we have the same behavior. So we have a decrease of the activity with the increase of the NAPL, but the variation of the partitioning coefficient is lower. We do not have significant variation between the fresh and the degraded gasoline. So here we have the GCMS results. So it is the headspace GCMS results for up the fresh diesel, the middle the UV degraded diesel, and lower we have the evaporated diesel. So what we can see is that we have alkanes, that's for the fresh diesel, and some other cyclohydrocarbons. And when we degrade the NAPL under UV, we have the same peaks. We don't have the dispersion of any peaks, but the intensity of the peaks are lower. That we can have is that the fresh diesel is the UV degraded diesel is 73% the fresh diesel about the intensity of the peaks. And concerning the evaporated NAPL, we have a strong modification of the chromatogram pattern. As we can see, the beginning of the chromatogram just disappeared, and we lost about 13 minutes of the chromatogram pattern. That was because of the evaporation of the most volatilized compounds. And after that, when we go check in the literature, the coefficient partition of some molecular compounds, what we can see is that the beginning of the chromatogram pattern is we have high coefficient partition for some such as arsine and cyclohydrocarbon, and that could explain the diminution for diesel, the diminution of the coefficient partitioning for the evaporated diesel compared to the fresh diesel. So what we can say about this study is that we studied the variation of the partitioning coefficients for different fresh diesels, so NAPLs, it was diesel and gasoline, and the mixture degradation under evaporation and photooxidation. The results show different partitioning coefficients, as we can see, for the fresh diesel and the gasoline, and it was similar from what we recorded in the literature. However, we have an effect of the degradation for the partition coefficient for the diesel, but not for the gasoline. And what we can see is that when we lost the beginning of the chromatogram, we have all the high coefficient partitioning for those, and that could explain the decrease of the coefficient partitioning for the evaporated diesel. Concerning the molecular characterization, there is no variation of the pattern between the fresh and UV diesel. However, we lost, as I said, the beginning of the chromatogram for the evaporated diesel. So this coefficient partition is of pivotal importance when we deal with quantification of NAPL in the soil with this technique, as this takes place in the calculation of the residual saturation. So if we just put inside the model fresh NAPL coefficient partition, we can maybe underestimate the quantification, the final quantification of NAPL in soil. However, future researches are still in progress. It is about the evaporation intensity, because we just did one evaporation intensity. It was 50% of evaporation. what happened for the diesel coefficient partition when we evaporate more or less. It could be interesting also to deal with the microbial degradation of NAPL, and after that see how the coefficient partition can change, and combine different parameters such as the combination of evaporation and UV degradation. Thank you.
Okay, thank you very much, Matthew, for your presentation. And so there will be space for question at the end of this session. So now I would like to invite Irina Yevrosimov. Are you there?
I'm here.
Okay, well, thank you. So Irina is a PhD student in environmental protection at the University of Novi Sad, Department of Chemistry, Biochemistry, and Environmental Protection. Her research area is about physical and chemical interactions in the environment with focus on the fate of organic pollutants in the presence of carbon-based material. And the title of presentation is Impact of Inoculated Biochar on Transport of Selective Organic Compounds Through Porous Media. So please, Irina.
Okay. Good afternoon. Thank you very much. I'm coming from Novi Sad, Faculty of Sciences, Department of Chemistry, Biochemistry, and Environmental Protection. And objectives of this study is to investigate the transport and biodegradation of two selected organic compounds, allochor and pentachlorbenzene, through alluvial Danube sediment, the impact of carbon-rich material, biochar originated from Miscanthus giganteus on sorption and biodegradation of these compounds, and the effect of added biofilm on degradation of allochor and pentachlorbenzene. The Water Framework Directive has included allochor and pentachlorbenzene in the list of priority pollutants that pose a significant risk to aquatic environment. The main processes which control organic compounds' fate and behavior, soil sediment, are sorption and biodegradation processes. Methodology included the synthesis and inoculation of biochar, characterization of Danube alluvial sediment and biochar originated from Miscanthus giganteus, and column experiments. Synthesis and inoculation of biochar, application of slow pyrolysis of the investigated biomass originated from Miscanthus giganteus at a temperature of 400 degrees Celsius. And Bacillus megatherium was isolated from the investigated alluvial sediment sample and used for inoculation of biochar. Characterization of alluvial sediment and biochar. Organic matter content of the alluvial Danube sediment was determined by shown standard. Total organic carbon of investigated alluvial sediment was determined by total organic carbon analyzer. Specific surface area, average pore diameter, and pore volume of all investigated adsorbents were determined using nitrogen absorption, desorption analysis with an analyzer for the characterization of porous and powdered materials. Carbon and oxygen content on the surface of all investigated adsorbents were determined by scanning electron microscopy with energy dispersive X-ray spectrometry. In this picture, we can see column experiment with sediment, sandy aquifer material and inoculated biochar. Column was filled with sandy aquifer material and inoculated biochar. Inflow solution was introduced using a peristaltic pump into a column from the bottom, and samples was collecting from the top of column and analyzed on GCMS. Result, physicochemical properties of fused adsorbents shown that the higher pore volume and carbon content was observed for biochar originating from Miscanthus giganteus than from alluvial Danube sediment. Total organic carbon for Danube alluvial sediment was 1.02 milligrams per gram. Danube alluvial sediment is highly permeable soil, and grain size distribution, including sand particles, fine sand, and clay. Sand particles is more than 65%, fine sand particles is 15.5%, and clay about 10%. In this picture, we can see breakthrough curves of investigated organic compounds without and in the presence of inoculated biochar in Danube sediment column. We can see the breakthrough curve of thiourea as a non-sorbing substance was symmetrical, and which shows absence of physical non-equilibrium processes in porous media. In this table, we can see transport parameters for the investigated organic compounds obtained through a column filled with alluvial Danube sediment without and in the presence of inoculated biochar. Column experiment with alluvial sediment shown the increasing retention time with increasing molecular hydrophobicity. Column experiment with alluvial sediment and inoculated biochar showing increasing retardation of both organic compounds with addition of inoculated biochar, and the highest biodegradation was observed for pentachlorbenzene, but for allachlor biodegradation was not observed. Conclusions, higher pore volume and carbon content were measured for biochars than from alluvial sediment. Transport of organic compounds through the sediment column showed that the retention time increased with increase in molecular hydrophobicity, and the addition of inoculated biochar increases retardation of both organic compounds. The highest biodegradation was observed for pentachlorbenzene, lambda is 6, and could be a consequence of high adsorption on biochar and biosorption, while for allachlor biodegradation was not observed during any of the experiments. And overall, the results indicated that the addition of inoculated biochar to contaminated sediments has the potential as a remediation technique to inhibit the leaching of pollutants to groundwaters. Thank you for your attention.
Thank you very much, Irina. And very good timing. So now let's move to next presentation, and the presenter will be Andy Lowy. Can you upload or share the screen?
Yes, thank you, Rob. Should be coming through.
Okay, so let me introduce you. Andy Lowy is an environmental scientist with 9 years of in situ remedial design experience, serving as a technical sales manager for Prevectus Environmental products. Mr. Lowy's work focuses on technology selection and application of chemical oxidants, chemical reductants, and aerobic and anaerobic biological processes to remediate common contaminants, including BTEX, PHAGs, chlorinated VOCs, and more. So the title of this presentation is combining traditional and advanced in situ remedial methods to address source petroleum hydrocarbon mass. So please, Andy, the floor is yours.
Yeah, well, thank you, Rob. I appreciate that great introduction. So I'm excited to be presenting here at RemTech today. As mentioned, my name is Andy Lowy. I'm with Prevectus Environmental, and I'm coming to you live from warm and sunny Phoenix, Arizona. Today, we're going to be talking primarily about ISCO and some traditional and advancements on that remedial method in order to address petroleum hydrocarbon mass. So before we dive into the technical portion of the talk, I'll go over an outline of what we'll be discussing. I'll start off with a brief introduction to Prevectus Environmental. Then we'll get into what is in situ chemical oxidation, or what is ISCO, and we'll be looking at the mode of action, as well as oxidation potentials and how that relates to contaminant destruction. Then we'll get into 3 of the main recognized limitations that I see with ISCO, which are oxidant demand, contaminant rebound, as well as the longevity. And on the back end of the presentation, we'll look at ferric iron activated persulfate, as well as a couple case studies. So Prevectus Environmental was first incorporated in May of 2014, and we've acquired patents on both ISCUR and ISCO technologies, as well as methane inhibition. Our backgrounds here include environmental consulting, remediation contracting, and the development of advanced remedial technologies in order to successfully complete projects across the globe. And in order to help get this work done, we have turnkey design and implementation partnerships that help us out.
Oh, sorry,
so what is?
Excuse me, you do not want to share your presentation at the moment? You do that later?
I'm sorry, was it not coming through on the screen?
No, not yet.
Okay, I apologize for that.
No problem at all, no problem.
Okay.
That's
sorry.
much better, Andy.
I'm very sorry about that. I thought I had that sharing.
No, you're doing fine.
So I'll just pick up from here. So this is really where the presentation starts. And ISCO in its simplest form essentially is the removal of electrons from contaminants. And this is just a simplified chart that I like to show that shows that reaction. You can see a generic ISCO reaction occurring here in the bottom left. The other thing I like to bring up about ISCO is that it is a non-selective technology, meaning that it will not only target the contaminants of concern in the subsurface, but it will also target any naturally occurring organics as well. So let's get into some of the oxidation potentials. And this is a chart that essentially shows that the higher the oxidation potential, the stronger the oxidizer you're working with. So up here towards the top, you can see the common hydroxyl radical, which is used in FENS reagents. This has the benefit of being able to treat a wide range of contaminants, but it does have some drawbacks, which include a short subsurface lifetime, and it can also be difficult to apply in reactive soils. Below that, we have the sulfate radical, and this comes from common activated persulfate. And when I say common activated, I'm referring to any persulfate that's not activated with ferric iron. So that can include activation methods such as heat or sodium hydroxide. The sulfate radical can also treat a wide range of contaminants, and it also has the benefit of forming slower than the hydroxyl radical, which in turn allows for a larger radius of influence. In addition to common activated persulfate, our ferric iron activated persulfate technologies, Prevectox and Prevectox 2, will also generate the sulfate radical as well as ferrate. So you'll be getting 2 reactions occurring in the subsurface. Prevectox and Prevectox 2 can also treat a wide range of contaminants. And in addition, they offer an extended in situ lifetime with continual bioremediation production on the back end due to residual sulfate and iron that helps avoid contaminant rebound. So we'll talk about that a little bit more later in the presentation. As you move down the chart, you can see some lower oxidation potentials for things like ozone, hydrogen peroxide, and permanganate. So how do these oxidation potentials relate to contaminant destruction? Well, in the chart on the right, we can see our longer chain hydrocarbons for things like PAHs, DRO, and GRO require an oxidation potential of at least 2.5 volts to successfully remediate them. So in order to generate that much energy, that means you need to at least be utilizing the sulfate radical or the hydroxyl radical. And given some of the drawbacks for the hydroxyl radical, that's often why we're recommending persulfate in order to generate the sulfate radical. Some other common contaminants such as BTEX require less energy, such as 2.0 volts. And then you can see some chlorinated solvents down towards the bottom are about 1.5 volts. But if you're targeting those longer chain hydrocarbons, other common technologies like permanganate or ozone or hydrogen peroxide may not generate enough energy in order to successfully remediate them. So now talking about some of the three main limitations that I see with ISCO, the first of which is non-beneficial consumption. And when I think about the total oxidant that's required for a project site, this is really a mathematical formula of two components. The first component is your stoichiometric demand of your contaminants. So assuming you have a well-delineated site where you understand your soil and groundwater concentrations, you can easily calculate this for any oxidant. Just to give an example, if you have 1 pound of benzene in the subsurface, that requires approximately 50 pounds of persulfate to remediate. The second half is a little bit harder to quantify, and that's what I call the non-beneficial consumption. This is made up of things such as your soil oxidant demand, metals, organic carbon, potentially the decomposition of the oxidant if you're using off fast like peroxide. And the best way to quantify this is through a TOD test. And that's a total oxidant demand test that helps us look at all of those other things besides the contaminants in order to quantify how much oxidant we need. So this is something we strongly recommend here at Prevectus. And though we do realize that every day a lot of project sites are successfully remediated without this test being done, it's essentially a little bit like gambling, as I've seen these TOD tests range between 2 to 3 grams per kilogram for a site, all the way up to 30, 40, 50 grams per kilogram. And what can occur is if you're assuming too low of an oxidant demand, you may be underdosing your site. And if you assume too high of an oxidant demand, you may be putting in more material that is required for your site, thus costing your client more money. So what in turn we do is we strongly recommend a TOD test here at Prevectus, and this is something that our partnerships can help to get done for you if you have a project site. The second issue that I see with ISCO is related to contaminant rebound. This is a study from McGuire et al. And what it shows here on the right are project sites that utilize chemical oxidation technologies. And on the left are project sites that utilize enhanced bioremediation technologies. Unfortunately, we don't know anything else about these sites, whether that's related to the geochemistry or the site geology. But what our takeaway here is with the chemical oxidation sites at time 0, we can see significant contaminant reductions. And as our timeline moves farther out to the right, we see less and less reductions occurring. This corresponds with our understanding of ISCO technologies, being that they typically react fast in the subsurface and run their course fairly quickly. When we look at the chart on the left with the bioremediation project sites, we see at time 0, there's very little reductions. And as our timeline progresses out, we see more and more reductions occurring. And this corresponds with our understanding of bioremediation project sites, being that they tend to be a lot slower on site. The real sweet spot here would be is if we could combine the ISCO with the bioremediation in order to get those rapid upfront reductions, as well as the sustained reductions on the back end through bioremediation. The third issue I see with ISCO is just related to the longevity of the reagents. So let's think about a hypothetical project site, or maybe a plume's been leaking in the subsurface for 2, 3, 4 decades. And over time, that plume gets delineated, technologies get evaluated, a RAP gets submitted, and finally it's time to go out and implement what's been approved, which may be a chemical oxidation technology. Well, over those decades, that plume has had the opportunity to migrate into very fine grained pore spaces in the subsurface. And if we look at putting an oxidant in that may only last, minutes to hours, maybe a couple months on the high end, that may not reach every potential little pore space in the subsurface. And this is a chart that I like to show from the EPA, even though it's a little bit older, as some of these technologies are listed as developing or experimental or emerging. And I think by now most are widely accepted within the environmental industry. But the column to the left of that related to the persistence still holds true. And we can see things like fentans and ozone. Those typically only last minutes to hours, whereas persulfate and permanganate may last a little bit longer, from weeks to months. So here at Prevectus, we offer two technologies known as Prevectox and Prevectox 2. Prevectox is sodium persulfate and Prevectox 2 is sodium and potassium persulfate, and both technologies come with a ferric iron activator. These technologies yield chemical oxidation via the sulfate radical as well as ferrate. And what they do is, following the application, they will alter the initial background reducing conditions, create aerobic conditions for oxidation, and as that attenuates back towards the reducing baseline conditions, the residual sulfate and iron reduction processes will remain in place to help sustain bioremediation on the back end. In addition, for both these products, we also include a TerraOr pH buffer, so we don't see that precipitous pH drop following an application with, say, a common activated persulfate technology. And our materials are very safe and easy to work with, as they're all-in-one products, and they come in either 50-pound bags or super sacks, depending on the scope and scale of the project you'll be working on. As I mentioned, Prevectox 2 is a combination of sodium and potassium persulfate. And the reason that we combine those two is that potassium has an order of magnitude lower solubility than sodium on site. And what this offers is an extended release profile for the oxidant that can last for months compared to just a few weeks. In turn, in the field, this allows us to apply Prevectox 2 in permeable reactive barriers, as well as open excavations for soil blending approaches. So let's dive into a couple case studies that we have here real quick. The first one, I'd like to thank Engineering and Land Planning for working with us. They're a firm based out of New Jersey, and this site's located in Madison, New Jersey. And what the client did out here initially is they did an excavation of the overburden, but this was limited due to the depth and the building on site. They also performed an EFR event on the front end to remove most of the LNAPL. And what this left us with for in situ work was approximately a 1,500 square foot area, with our target vertical zone from 25 to 40 feet below ground surface. The depth to water at site was about 30 feet, so we were targeting the smear and saturated zone out here, and the site geology consisted of dense silts and clays. The contaminants of concern were BTEX and trimethylbenzenes, along with a little bit of residual LNAPL in one of the two wells. And in turn, we applied 8,500 pounds of Prevectox in order to significantly reduce the contaminant mass. And one of the key takeaways is that the business was allowed to remain active and open during these injection activities. So before we get into the VOC data, we do have some geochemistry. What we can see from the baseline conditions in our two target wells is that initial conditions were strongly reducing, with ORPs being greater than negative 100 millivolts. Following the application, we can see that the geochemistry quickly flips to aerobic, with the one well going as high as plus 354 millivolts. And then about 3 months post-application, the ORPs return back to their reducing conditions, which is what we would anticipate based on the longevity of the oxidant. And then we'll have that sustained bioremediation with the residual sulfate and iron to help take place on the back end. Additionally, looking at our pre and post-application pH, we see that that stayed around 7, with only a small drop to about 5.9. This is due to that pre-blended buffer that we included to help maintain pH. So we don't see that steep drop down around the 2 to 4 range. And getting into some of the VOC data at MW6R, we can see reductions of greater than 90% for both the BTEX and trimethylbenzenes. At MW9R, this is the well where we had a little bit of residual LNAPL that was successfully remediated. And we did have some higher starting concentrations here. The BTEX was reduced by approximately 96%, with the trimethylbenzenes coming down by about 85%. The thing I'd like to note is that this is only about 12 months post-application. So even though the oxidation reactions have kind of run their course, we would still expect the bioremediation to continue for years to come on the back end. The second case study we have here is from a site on the east coast of the US. This was an excavation where they applied Prevectox 2 to the base of the excavation and blended that in with the residual soil and groundwater. You can see the picture here on the top right with one of our super sacks being opened and the Prevectox 2 being dumped out. We saw fantastic results at this site as well, with the BTEX going down between 94 to 100% and the naphthalene being reduced by about 84%. And the client was very happy in the end, as the remedial goals for the site were just significant mass reduction with long-term monitoring. So I do thank you for listening to my presentation today. Just a reminder for us at Prevectus, we do offer complimentary site evaluation. If you're working with us now or have in the past and would like us to take a look at any project data, we'd be happy to do that. As mentioned, for TOD tests or bench scale tests, we also partner with labs to do treatability studies. And then whatever your scenario is, whether that's turnkey, pay for performance, or contracting options, we'd be open to evaluating it. Lastly, I'd like to thank our local partner, BAW Remediation Technologies, and Claudio Sangerone. His contact information is below. If you're at the conference in person, please feel free to visit them at Pavilion 3, booth number 1. And then if you'd like to learn more about Prevectus or talk with me about a project site, here's my contact information, and I thank you for your time today.
Thank you very much, Andy, for being with us during this Remtech conference. And so now, Frank, I don't know, do we received some message from Marco if we can go for next presentation, or we will do panel discussion? Microphone.
Hi, Robert, I'm online now. Alberto is traveling, and I don't know if you can hear us. Alberto, could you switch on your mic? Okay, you can hear us. Okay, if you...
I don't know if you can see me.
Yes, we see you in the car. Very well. I will try to share my screen. Just a moment.
I can try, Marco. I can try to share my screen because
better in this way, Alberto. Probably we will avoid any kind of problems. I don't know. You have I don't know which kind of line you may have. Better that I share. I have, however, here. Just a moment. I try to share your presentation and put it in full screen mode. Frank, Robert, and Tom, you see the presentation from Alberto well?
Yes, we do.
Okay, yeah. Perfect. Alberto, let's do in an old-fashioned way. Next slide, please. Okay. So I will be at your disposal.
Okay. Thank you very much, Marco. And sorry, but I'm traveling up to Ferrara for Remtech, so because we have a stand in the next days, so, and presentation in several sessions. So in this session, thank you for the opportunity. And in this session, we'll try to summarize a recent case studies where we apply technologies for the treatment of hydrocarbons in groundwater. In particular, before jumping in the presentation, just a few words on Peroxic. Please, next slide, Marco. Okay, we will just make a brief overview about Peroxic as leader in the remediation sector for groundwater and soils. And then we will focus on the case studies and in particular application method, the chemistry at the basis of the technologies. Please, next one. Okay, in particular, Peroxic is leader in the environmental sector for promoting the technologies for remediating contaminated soil and groundwater. We tend to support the client from the start to finish in a project. So from the evaluation phase, trying to understand the best remedial solution until the design phase and the post-application phase. Moreover, we provide tech support during the field activity, in particular supervision on site, in order to check that everything is well done. Next, please. In this slide, we can summarize the peroxic technologies for the remediation of soil and groundwater. In particular, we can summarize the technologies in 6 main categories. Technologies for chemical oxidation, technologies for chemical reduction, technologies for aerobic bioremediation, technologies for biogeochemical treatment, technologies for the medial remediation, and technologies for enhanced reductive dechlorination. And in particular, in the next slide, we will focus on the closure CR technologies is for chemical oxidation and at the same time aerobic bioremediation of organic contaminants such as hydrocarbons. Please, the next slide. In this slide, we can see an overview of the peroxic treatment technologies along with the different typical contaminants that we can find in a site. We can observe how the closure technology is the one that we are going to present. Is between between the hydrocarbon family and the chlorinated solvent family, because thanks to the activated persulfate, we can treat both organic contaminants in a site, in particular, or in groundwater, or in soil, or in both components. Please, the next one. Okay, this is the slide about the closure. Closure family is based on sodium persulfate and consists on several high-quality environmental grade persulfate products used for chemical oxidation of contaminant in soil and groundwater. Please, the next one. Okay, we produce Peroxicam is leader in the persulfate chemistry, is a patented technologies, and is one of the world's largest producer of persulfate. We have facility in North America, in Europe, and we support clients on apply the persulfate in the best way ever. Please, next one. Here the closure portfolio. In particular, we can see 4 different products. We have Closure SP is the pure sodium persulfate. And when you apply the pure sodium persulfate, you need to use an external activator in order to maximize the efficiency of the reagent. Closure 1 is the sodium persulfate with a built-in activator, so everything is in the product, and you don't need an external activation. Closure SP is the potassium persulfate. Is a particular persulfate that lasts in the media up to 6-9 months after the injection. And the last one is the closure CR, where CR is the acronym for combined remediation. Remediate is approximately 50% sodium persulfate and 50% calcium peroxide. So when you apply this product, you have at the same time a chemical oxidation, bioremediation, aerobic bioremediation, and the calcium peroxide of the product can activate the sodium persulfate. And this is the technology that has been applied in the next case studies. Please, the next one. Yeah, the closure in particular, some just details on the technologies. The technologies is all-in-one product, so you don't need external activation because, as I said, the calcium peroxide, the alkaline condition of the calcium peroxide in groundwater activate the sodium persulfate. So it can be easily applied for treating organic contaminants such as hydrocarbons, or at the same time chlorinated solvents, mixed plume with chlorinated solvents and hydrocarbons. Please, the next one. Closure CR can be applied in the source zone, so at the bottom of the excavation pit, or using direct push in the most contaminated area, or, for example, using common methodologies such as direct push or fixed tubes, or in trench along the plume, in order to stop the migration of the contaminants outside the site. Once we apply closure CR in the groundwater, we usually observe three different reaction. Chemical oxidation, thanks to the sodium persulfate activated by the alkaline condition. Aerobic bioremediation, thanks to the calcium peroxide that release oxygen over time for a period up to 9-12 months from the injection. And then, as last step, we have anaerobic bioremediation, thanks to the residual sulfate and the residual hydrocarbons. Please, the next one. So the product can last up to 9 months with just an injection in groundwater for treating the contaminants. The product can be applied for the treatment of contaminated saturated zone. We can use the common injection tools such as direct push, fracturing, or fixed wells. However, we don't recommend fixed wells because the calcium peroxide can clog the drain of the well. So in case we want to use fixed injection point, we recommend, for example, manchette tubes technologies. And lastly, closure CR can be used at the bottom of the excavation pit. So in order to treat the residual contamination after the excavation of the most contaminated soil. Please, the next one. Okay, the technologies has been successfully applied in a very contaminated site in the center of Bologna. And if you can please go ahead, Marco. As we can see, a former petrol station in the city center of Bologna has shown an high contamination of hydrocarbons in groundwater. In particular, the treatment area was up to 350 square meters with a treatment area thickness of approximately 5 meters, between 4 and 9 meters below ground level. The aquifer is a silty sandy aquifer with a low permeability condition. In fact, the seepage velocity is approximately 4 meters per year. Before the treatment, the aquifer has shown moderate anaerobic condition with neutral pH, and the contamination levels were approximately of 2 milligrams per liter of heavy diesel, the total petrol hydrocarbons, in particular in the diesel range, benzene, ethyl benzene, and very high contamination of MTBA up to 10 milligrams per liter. We can see in the map the injection point in red and the monitoring wells. Please, the next one. We performed two different injection campaigns. The first injection campaign in February 2018, the second in April 2019. In both cases, we applied the product through 18 injection points distributed as a grid mode in the most contaminated area. During the first campaign, we applied approximately 190 kilogram closure CR per point. Second campaign, 160 kilograms per point. And in order to reach the regulatory limits of as shown in the slide, so 1.35 for the total petrol hydrocarbons, MTBA 0.074, and benzene 0.081. And we achieved in less than 2 years the cleanup goals with a reduction up to 90% for MTBA and 80% for total petrol hydrocarbons. Please, the next one. In particular, we can see for the total petrol hydrocarbons, after the first injection campaign, we can see an increase in terms of contaminant concentration due to the alkaline condition, because the alkaline condition tends to desorb the hydrocarbons from the soil matrix. And this is very helpful in order to remediate a site, because you remove the secondary source. That is one of the main reason when you have rebound effect. So after the first injection campaign, we still observed some contamination level above the limits in some monitoring wells. So that's why we performed the second injection campaign. After the injection campaigns, we reached the cleanup goal in all the monitoring points. Please, for the total petrol hydrocarbon. Same results for the MTBA. Please, the next one, Marco. Same, the next one is still about benzene and MTBA. Yeah, we reached the cleanup goals after the second injection campaign, because we observed the same phenomena after the first one, with several oscillation in terms of groundwater contamination level, thanks to the desorption of the contaminants from the soil, the saturated soil matrix. The next one. We also monitoring the field parameters in order to verify the good distribution of the reagent in the aquifer. And in particular, we can see the redox potential and the dissolved oxygen. In both cases, we measure an increase of redox potential thanks to the aerobic condition of the reagent, and same for dissolved oxygen, thanks to the slow oxygen release from the calcium peroxide part of the product. Please, the next one. Okay, so conclusion, the closure cyan has been successfully applied in this former petrol station in the city center of Bologna. And so we demonstrate how persulfate chemical oxidation can be successfully combined with aerobic bioremediation to treat petrol-based contaminant. Combination of persulfate and engineered calcium peroxide, such as Permeox, because Permeox Ultra is the component of closure CR, so is the 50% of closure CR, can provide quick ISCO and long-term enhancement to aerobic bioremediation. The closure CR lasts in groundwater up to 9-12 months with just an injection, allowing the treatment of the contaminants in groundwater with no stress for the bacteria population. And in this case, the remediation goals were achieved in all the main monitoring piezometer of the treatment area without any rebound effect in the area, demonstrating the good distribution of the product and the successful treatment of the contamination. Monitoring data confirmed high level of oxidant reduction potential and dissolved oxygen level were sustained to support continuing enhanced aerobic bioremediation. And the next one. Okay, thank you very much for your attention, and sorry if I'm traveling and so for the poor connection.
We were resilient, Alberto. We found the solution also in difficult conditions. I hand over the line to the chairs, Frank, Tom, and Robert for the discussion panel. Stay online, Alberto, as well as other speakers. Frank, I have to go to the other session. I hand over to you.
No problem, Marco. Thank you. I would like to thank all speakers. I think we had a very interesting session. Some of you make it look like it is all very easy, but we all know there's a lot of knowledge and science behind all the solutions. Regarding the discussion, we have this slight problem that we have only 9 minutes left. I have a whole bunch of questions myself. There are a number of questions on the chat. It doesn't make sense to go to all the questions in 9 minutes, so I like to propose another procedure triggered by the question of Nithal Boutalbi. And that was a question to Jan, but I actually like to raise the questions to all speakers. Jan Hamers at the beginning, that the thermal desorption is one of the most sustainable remediation technologies. Sustainable in my world includes a healthy soil ecosystem. So the question is, and that is indirectly also the question of Nithal Boutalbi, how does your thermal desorption disturb the soil ecosystem and also the soil structure? And in a general way, I would like to ask you, Jan, and also the other speakers, what is sustainable about your solutions that you have to offer, in this case, thermal desorption? Can you maybe expound on that a little bit, Jan?
Yeah, of course. Well, thanks for the question, and I'll first answer the technical question that was asked about thermal. What was the result after the treatment? It is the main important one, and I'll get back to that about sustainability, is that there is no contaminant left behind. But given the temperature we reach, there is essentially no organic matter either. So there is no life anymore. So the material after treatment is sterile. Now, does it get back? No, but that doesn't mean that it's completely useless, because it is still soil. And that's the big difference between, say, thermal desorption and incineration. Incineration would just provide an ash, which is completely useless. You cannot grow anything on that. On thermally treated soil, anything you seed will get back to life and will grow again. So it still has a texture, the structure and a texture of the soil, and can be used for that. So that is just the technical approach. And by the way, it's been widely used. For example, I don't know, Daniel, what's going on. It's been widely used, for example, thermally treated soil for rolling lawn that you would buy, because they prefer to buy that than to buy natural soil, because of course it has no weed in there. So whatever you put in there, whatever nitrogen or potassium or calcium you put, you could really make it as you want. So that is just for the technical question. Thermally dissolved soil does not contain any organic anymore. Now, with regard to the broader question about sustainability, and if you look at the publications that have been published over the recent years, which finally ranked like in situ thermal absorption #1, or at least in the top 3, the main issue here is, what are we doing? We are remediating soil, all of us. And why do we do that? It is to give back to society healthy land that they can reuse and do whatever society wants to do with it. And you're old enough, Frank, to remember the first laws in the Netherlands with multifunctional, and the way we no longer apply that, not because it was not a good idea, because it was too expensive. And if we had a solution to remediate in a multifunctional way for a very affordable price, everybody would do that. Nobody would talk about risk anymore, because sustainability is foremost not transferring the liability we inherit to our children. So any technology that just kind of remediates, leaves contamination behind, leaves it as an acceptable risk, we have to admit that that risk is just an evaluation. It's highly variable in time. It can change. It is still a way to cope with risk, not to really deal with the problem. And the high levels of sustainability is recycling land. Make sure you can do whatever we as a society want to do with our land once it's remediated. Not just say, oh, it used to be this industry, we'll leave it as industry. And in the meantime, we're going to put our housing miles farther away. We're going to see our cities sprawl, and we're going to see our agricultural land surface, reduced and reduced and reduced decade after decade. That's also the global picture about sustainability. And I guess when you read this publication, this literature, that's why, making sure that you have zero contamination left behind is an essential parameter in sustainability.
Okay, Jan, that sounds convincing enough. Unfortunately, Jelenka left. That is a pity, because I had some questions for her also. Marcelo, can you maybe expound a little bit also on Petrofix from the perspective of sustainability? Is it sustainable, or can you make it, what could you do to make it more sustainable?
Yeah, probably. I believe Petrofix would be probably one of the most sustainable products we have in the platform of product that Regenesis offer. Probably Petrofix and Plumstop, which are both colloidal activity carbon, would be in the highest range of sustainability between all our products. Also because when you approach those solution, especially talking about barriers approach, really you can go with complete passive management. So the activities on site are really minimal, just for depending on the size of application, but we are talking about small equipment, a few people on site application, and then for the following years, and I mean, it could also be some decades, we just then go back to site and monitor if application and if the reactions are still taking place and if the plume is still under management. So we are really turning from the concept of injecting and then go back repeatedly on site to complete passive management, which is probably the most sustainable thing we can think about.
Marcelo, how long is a Petrofix barrier effective?
Good question. So activated carbon remains activated, we believe, around probably a century or periods like that. And there is no understanding of the fact that we are creating a colloidal form, that these would last less. So the activation process would literally be there for much longer than we need for. So it's probably another scale compared to the need for the remediation purposes. Then what we are really working into, it's the regeneration process. So trying to create designs which then are self-sustained, which means that we need to create and enhance a biodegradation process which frees up space on the activated carbon. So our main goal is there. So to ensure that we enhance primarily the biodegradation process and that this is in place and that these after the enhancement then can continue self-sustained thanks to the electron acceptors or electron donors, which naturally are occurring on in the subsurface. So is this biodegradation process which makes then that carbons they are available for our needs.
Okay, thanks a lot, Marcelo. You know, I challenge you a bit to the word sustainability is easily used. I challenge you a bit to make it more concrete in the perspective of remediation solutions here. Mathieu, you did not really offer remediation solutions, but you really did research on the partition coefficients. May I also challenge you to tell the audience how this contributes to sustainability?
Yeah. So as you said,
difficult question,
yeah.
I think.
Yes, because I work only in the lab now, and I did not upscale yet on the field the use of radon. But yeah, it's not really remediation. I'm before the remediation because I'm just trying to detect and localize an apple using radon. And it's really a small scale now. It's just batch experiments, but I think we got good results at the beginning because we now have the the knowledge about fresh apple and degraded apple and the change of the partition coefficient. So what we do now in the lab is try to use this kind of partition coefficient variation and using them in models. So we developed a model in the lab, and we try to upscale now for column experiments. So we have a soil column experiment, and we inject inside NAPL. Also, it's a 2-meter column experiment, and we try to see if we inject degraded NAPL or fresh NAPL, we can simulate the variations of the radon activity. And in the final way, it will be to upscale again in a field site, a small field site contaminated, and try to see if we can really use the partition coefficient as we studied at the beginning to upscale until the field scale.
Okay, thank you very much. Irina, about the inoculated biochar, can you tell us how this contributes to a more sustainable world, a more sustainable soil management? Also a difficult question, I realize that. Are you still there, Irina? She is not. That is a good way to avoid difficult. Oh, you are there. Okay.
I hear you.
Hello, Irina.
In further research will be focused on that.
In which way? Can you expound a little bit on that?
We haven't researched it yet, but further research will be focused on that.
Okay. You want to keep it with this for the moment, Irina? That's okay. Yeah. Okay. Yeah. Let's go to Andy. ISCO, a quite traditional remediation technology. Can you say ISCO is sustainable, or do you see options for making it more sustainable?
Yeah, absolutely. Thanks for the great question. And I think what we've done with both of our Prevectox and Prevectox 2 technologies is really enhance the sustainability of ISCO. So with Prevectox and Prevectox 2, you're going to get the ISCO reactions occurring on the front end due to the sodium persulfate or the combination of the sodium and potassium persulfate blend in Prevectox 2. And then on the back end, you'll get sustained bioremediation occurring due to the residual sulfate and iron. So essentially both products act as a dual functioning technology with the ISCO on the front end and the bio on the back end. And then just going back to the ISCO, what we've done to help enhance the sustainability from Prevectox to Prevectox 2 is include the potassium persulfate in our blend, which helps give us an extended release profile for a few months compared to a few weeks just for the sodium persulfate alone.
Okay. Alberto, also on ISCO, anything to add about closure in relation to sustainability? Or Alberto probably left driving the car.
No, can you hear me?
Oh, you're there.
Okay,
Yes.
perfect. Sorry, I was just on mute. Yeah, about sustainability, our technologies are green technologies also in terms of production, because Peroxicam is very careful about sustainability. So we tend to use recycle material in order to be green as much as possible, and at the same time pure material. So the technologies, for example, closure CR is also sustainable in terms of remediation, tend to limitate the carbon print, so the carbon produced during the activities. So trying to minimize as much as possible the carbon print. So sustainability is one of the main goals of Peroxicam.
Okay, thank you very much, Alberto. Time is up. I look at my co-chairs. Do you have anything, an important question or issue to ask or to raise, Robert or Tom?
Could I just ask one question, given we've got a few speakers here, thinking particularly Andy, Alberto, and I'm sure Marcello can comment on this as well, just in terms of the sort of longevity of the oxidant compounds and some of the comments that were made. Could they comment on how quickly these die out or are used up within the systems, and obviously then the follow-on to the sort of bio processes that were talked about? I'd be very interested in comments on that.
Yeah, well, I can jump in first here, Tom. So for our technologies, the ISCO reactions, whether that's Prevectox or Prevectox 2, those will typically last for a few months to weeks. And then the sustained bio on the back end, that'll typically last for years. And we've seen that longevity range between 3 to 7 years on the long end. And so that'll have a little bit of variability depending on the amount of oxidant that's applied, the site, the amount of contaminants that are present. But I hope that helps kind of give you a little bit of a time frame that you're looking for there.
Jan, you had something to ask or to add?
Yes, it was more, if I may, just a general comment on sustainability. Sometimes you hear that, and I really want to make a point on that, on mistaking carbon footprint for sustainability, in particular in our sector. And I think sustainability is much wider than that. It is really trying to find a balance between society, environment, and economy. And it is not just carbon footprint. If we applied this pure carbon footprint measurement, we would all do landfill. We just take it, dig and dump is the lowest carbon footprint technology of all. Or even just pouring concrete on a piece of contaminated land, leave it there, go somewhere else. It's the lowest carbon footprint. So I would just encourage everyone, when you do sustainability assessments, to look at the much larger picture of really sustainability. and not just look at something that is easy to measure. And this mistake is made in many fields where we tend to focus on what we can measure. What there is a very simple metric, and we focus on that, losing the whole picture of what we try to achieve, which is true sustainability. Make sure we don't transfer something worse to our children than what we receive from our parents. So that's the comment I just wanted to make after the whole sessions and the discussion about sustainability.
I very much agree with you that sustainability is more than footprint. That's a very good addition, Jan. We have to end the session. I think we had a very interesting session, and there is hope for oil and hydrocarbons. We saw a lot of excellent solutions. I would like to thank all 7 speakers for their excellent contributions of this session. What I will do for those who put questions on the chat, I will see, I cannot promise, but I will see if these questions can reach the speakers, and they maybe might give an answer by email. Thank you very much. Here you see the remaining part of the conference. You can continue this afternoon with 2 interesting options. So I wish you a very pleasant proceedings of the conference. Bye-bye, everybody.